Hello everyone, here we are again. Today we are with this problem in which we need to find out the minimum size of plane mirror required in order to a man can see his full height. So let's start from this man. Suppose this man has height h and we put uh, any mirror in front of him, and we will try to find out the minimum size of this mirror so that it can see its full image in this mirror. This man can see its full image in this mirror. This is what we are trying to find out. First of all, we will see that from this top point a ray of light travels to the mirror and reflect back to his eyes. This is the way he sees his head in this mirror. So we draw the lines here it is. So we can see this from there his head, this line comes and incidents on this mirror and reflect back to his eyes, and in the same way he will see his feet when light ray travels from feet to the mirror and then reflect back to his eyes. This is the representation of light ray. This is the representation of light ray which is coming from his feet and incidenting on his eyes, and this is the light representation of light ray which is coming from his head and reflecting back to his eyes. This would be the minimum size of plane mirror which is required. Greater than this placed in particular position can be can allow this man to see himself on this mirror. So we will draw a complete sketch for this complete light ray. This light ray, it looks like this light ray is coming from this point, and this light ray will looks like it is coming from this point. So the image will be formed here. This is the image. We can see that this is the image of this man which man see in this mirror like this. Okay, and it will also be of same height h. This is the property of our plane mirror. So we can see this on so this man can see himself as same height in this mirror. Suppose this mirror has suppose we can say that this mirror has x length. Suppose the size of this mirror is x. This is the minimum size needed. Okay, now what we do, we draw a line, a straight line from here and in the same way we draw a line here and we give these 2 points where it intersects some name. So let's start. We give this point name. Let's change the color. We give this point we start from here. This P, then Q, this should be R, then S. So P, Q, R, S, and this is his eyes. This point is his eyes. So we give this name E. E for eye. We give it name E. Okay. Now we move to the mirror, and for mirror let's give name M1, M and M dash. As simple as it. M and M dash is the names for this. So we need to find out the value of x. The value of x would be we will see the value of x. Let's change the pen. Value of x. X would be equals to this q. X would be equal to QR. We can see here x would be equal to QR this size of mirror is replicates here, so x is equals to qr. Okay, now all we need to do is find out the value of qr. So start from here. We see two triangles here. One is PMQ and second is EMQ. They both are similar triangle. Why they are similar triangle? They both are similar triangle. And why are they similar triangle? First of all, they have their angle. This is 90 degree and this is 90 degree. Same angle. This side is common and these angles would be same. Why? Because I equals to r for the reflection of plane mirror. And in the same way, triangle EMR will be similar to the triangle SM-R. EM-R will be similar to SM-R. Why? These angles would be equal. This side, this common, and this angle is 90 degree. Okay, then if they are if they are similar, then from here we can write PQ equal to QE, and here we can write ER equal to RS. Let's write here ER equal to RS. What we are trying to do, we are trying to find out the size of this mirror. So we require to find out the size of x is equals to QR from this figure, as we clearly see. Now what do we do? Just find out the value of ER. So here h would be equals to, this height of man would be equals to PQ plus QE plus ER plus RS. ER and RS. Then as we can see, PQ equals to QE, so replace PQ from QE. This is 2QE now. And here as well, replace RS from ER, because ER is equals to RS, so 2ER. This is 2QE plus ER. QE plus ER would be QR. It would be QR from the figure. QE plus ER would be QR, and QR is equals to x. What we are trying to find out, 2 into x. X is the size of our mirror, so h is equals to 2x. This way h by 2 is equals to x. This is all we were trying to find out. We were trying to find out this size of plane mirror, minimum size of plane mirror required for this man to see his complete image. So we will need at least h by 2 of our height, at least 1 by 2 of our height, in order to see ourselves in the mirror. Minimum 1 by 2. But it is not necessary. If we have a mirror of half of our height, then we will be able to see ourselves in the mirror. It should be placed as it is shown in this figure. Elsewhere, if it is placed somewhere else, then it may or may not be possible for us to see ourselves in the mirror. That's all from here. Thank you.